So we go into here. Again, for anybody who's not watching every single one of these streams without fail, so this program is going to look the same as it has for a while. I'm glad it worked. I didn't test any of this on this computer, so it could have failed. You know, we're doing font rendering and stuff, and last night we worked on syntax for casting and making it a little easier to cast. And since then, this morning, I did go and change the keyword, so now it's $X. I'm trying it out this way. We'll see if I like it or if I don't. What this means is auto-cast the thing behind it. And I made certain other things work. So like you can do this. At the end of last night's stream, this didn't work. And I thought about it and I thought, should I make that an error or should I make it just elide these? Because this should have the same meaning as that. And I decided to just unwrap them at parse time so that you only end up with one. And the reason for that is if you have auto-generated code or something, you might end up with multiple autocasts stacked. So, whoops, I'm just running the same thing I ran, but I can hopefully do this and it'll work just fine. Yeah, it just gets rid of the extra ones in that case. You know, this is what yesterday that would have said acast, which is maybe more intelligible to somebody dropping in the stream and doesn't have any idea what's going on, but whatever. The other thing that I did was I did the top item on my to-do list that wasn't about casting, which was making integers be 64 bits large by default. So they were ints were signed 32 prior to today, and now they're signed 64. And I had to iron out one or two bugs related to that. But in general, it's working fine because as you saw, we were still able to run that relatively complicated program. You can cut the low frequencies in post, like I'm going to post this when I do it on YouTube. This is going straight to YouTube without audio editing at all. I do have a little paper towel under the mic. I'll slide it this way a little bit. Or I can put it on a pad of paper. I don't think that's going to matter. I don't think it's going to matter. In fact, it's now precariously on a pad of paper and may slip off. Do I consider anything like CC or other double letter? Yeah, let's just shut up about the syntax. Sorry, I don't mean to be super rude, but we've just talked way too much about what is really a minor issue. I did it yesterday because it was entertaining, but there are much more important things to talk about and think about than what the word is that means autocast. It's just way too much bike shedding at this point for me, so we're going to stop. Okay. So I don't even remember what I was thinking about wanting to stream today, so I'm going to look at my notes file. No, it's not that one. It's that one. Oh, yes. Sorry. So what I've decided after a while is, well, let me go to some code that we're actually using, like, okay. So in the Unicode, for example, you know, we're parsing out numbers and stuff, and I wrote my own little version of isDigit, which just tells you if something's a number. And we're using this syntax. We can have a different syntax discussion today. Rather than bike shedding about autocast, we can bike shed about something else. So a long time ago when I first did this, you know, the C equivalent of this is to do that, is to put quotes on both sides, and that seems like a waste if you're talking about one character. But putting just a single quote has some funny repercussions. Like if you're going to single quote space, it looks like that, which is weird. If you want to talk about the character space, that might confuse some people. Or, you know, if you put like a UTF-8 character in there, I don't know. Let me go. So let's take some Chinese character and put it there. you know, that sort of works, I guess, but it has some repercussions, like in terms of parsing the source code, because it's a multi-byte character, it's a little bit, there's just a little bit of a question there. I don't think there's a real problem, but you know, it's the other thing about this is just that there's just not that many reasons, unless you're doing string processing all day, which this isn't a language for, like, you know, shell scripts or something. This is a language for large structured projects. I don't necessarily see that it's worth spending syntax to mean a character the way you do in C. And so what I'm thinking about is maybe having a slightly more verbose thing that you do to indicate a character, but that frees up this single quote to be used for something else. And what I've been thinking about is this. Maybe you say hash char and then a string literal after that, right? So here you have a string literal. It's going to be multi-byte because that's Chinese, right? You could say char 9, right? And that would be legal. And if you gave it something that's more than one character wide, it would complain, right? That would be a compile time error. And oh, and if it was a space, right, like x is a space, you know, then that suddenly that's a lot less ambiguous, right? That looks better than this, which is, that's a little questionable, don't you think, right? And then now, then we get this character back, and maybe we'll use this character to mean autocast or something, and then we can have some more syntax wars over that. So that's my idea about what to do for right now. Let's see if anyone has feedback in the chat about what they think about this that I can take into consideration as I do it. Now, see, somebody's saying they like Python because you do something like this, right? You could do that in C, and you can probably do that in this language once we do a better string class, but that's not what you actually want, because this actually, there's multiple things about it. Like if you make a mistake, which will be easier with multi-byte stuff, like it won't tell you that you've made a mistake. You're also creating assets. Like this is probably going into the string table in your data segment, and then you're just it's just not what you want for a fast programming language. You want to refer to a character literal unambiguously, right? That's all. That's all I'm saying. Yeah. All right. No, I don't want, someone's asking about maybe autocasting single character. Like if you did this and it happens to be one character, no, you can't do that because a character literal and a string are different types, and you don't want a string changing to a different type just because it happens to be a different length. Like that's really weird. We're not going to do that. So I'm just going to do this, and we're going to, you know what we should do? We should write a small test program for this, just because I don't think I actually use lining figures in this program, and that's where, that would be our test of this. So let's write a small program with the old syntax, make sure it works. All right, so we're going to say, we'll just go in, well, okay. Fiddle with string, right? Takes a string. We're going to cast it to UTF or to U8 right away. We're going to say S equals cat. I'm not remembering the new syntax all the way. Okay, so now we have an array of U8s, and I'm just going to not worry about Unicode or anything, and I'm going to say len s for 0 len -1. I don't know, printf. First, let's just comma, C, right? So we're going to say C is S sub wherever we are. We're going to just printf that, and then we're going to new line. So here we're just printing a string. We're going to say, let's get rid of all this entity and whatever. We're going to say string, no, that's a keyword. Text is hello sailor, right? And we're going to fiddle with string text, which should just print it. And let's get rid of all our build stuff because we don't need any of that. This is a very simple program. Which one is it, Biff? Type mismatch. Argument 1 of call to Sterling. Oh, it wants a string. See, this is, I should one of these times do better string support because now I just have all this crazy casting back and forth. I guess I have an underscore S, that's fine. All right, so we get a hello sailor, so that's fine. So now I'm going to say if C is equal to O, then C equals, well, I don't really need the then. C equals, E, right? Else if C, I'm going to swap E's and O's, right? C equals O, right? So now we get Holly Sailor. So this will be a good test. Right, so here's our program, our brilliant, amazing program. Actually, let's print out both. We're going to print it out unmodified and then modified. So there we go. Oh, we have a new line in our string. Let's not do that. All right, so there's our program. Amazing. You've never before seen such awesome programmingness. Someone is asking, why do you want single characters to be different from strings at all? Because a character is not a string. A string can be very large. A string can be 4 gigabytes, and a character is going to be probably U32 because it's a UTF-8 character. It'll be a UTF-32 character, right? That's what it'll be. You don't want that to be a string for many, many, many reasons. You don't want a string to be an array of strings. That's just goofball. So yeah, it's no. A character is different from a string. That's what you want if you're an experienced programmer and you know how to program. Sorry, folks. That's just how it is. All right. Sorry, I shouldn't let myself divert too much into random questions, but sometimes they're good. I don't have enough of a filter on like which questions are going to be worth me answering for everybody on YouTube who watches this later. I need to get a real-time question rejecting filter. Okay. Maybe I can have a personal assistant who just picks which questions I answer on the stream. All right, so this is our test program. Now I'm going to break it by doing this. I'm going to say if it's equal to that. Actually, hold on, because, sorry. I want to keep the old version around because after we make our changes, I'm going to want to make sure that the old version at least generates good error messages, right? Because it's going to be weird because we don't use this token anymore or whatever. So this is what we're saying we want the new thing to be. Okay. Now if I try to do this, if I try to run this, it's going to say something about unknown directive. Is there a reason I feel like not changing char type to just be byte type? Well, if you're Unicode, a character is bigger than a byte, for sure, right? In fact, maybe 32 bits is not even enough, but it's going to be 32 bits right now, and it's going to be a U32. And then, if you want to put that into a string, then you have something that takes a U32 and puts it into a string. So in general, the native strings in this language are UTF-8, which means that assuming you want to actually be UTF-8 clean in your program, you need to consider that any particular character is an unknown number of bytes long, right? So it's not like ASCII anymore, where a string is an array of things that are the same size. The things in a UTF-8 string are different sizes, which is, you know, not necessarily ideal, but it's probably better than using UTF-32 strings, because that takes really a lot more memory. It does complicate string processing a little bit, but assuming that all your string processing calls are relatively abstracted, it's probably fine. I mean, we'll see how it works out, though, as the language comes along. Yeah, someone's saying hashchar is verbose. Yes, it is more verbose, but that's fine. So let me make an analogy to data compression, right? It's actually, you know, you can use a program like zip or something to make data smaller. But actually, in general, it's impossible to make data smaller in the general case, because if you compress some things, you have to make other things bigger. That's like a law of information. There's no way to get around it. But the way compression algorithms work is that they look at what kinds of things you want to be small and makes those smaller at the cost of making other things that you don't care about bigger, right? So as long as the things that get bigger are things that you're never going to put into your zip program, then you're fine, right? This is the same principle. You don't want character literals very often. Like, I program a lot and I hardly ever use character literals. In a large program doing non-trivial tasks, like I'm writing a compiler that processes, you know, input from a text file and parses and does all this stuff, and I don't even care about character literals there, right? So it's making this trade-off, right? It's doing something that's more verbose in an area that we don't care very much about because it's very rare, in order to free up some other things in the language and be able to leverage them elsewhere, right? So now we get something, we can do this to mean, I don't know, like arbitrary infix operator, the way that Haskell does, if that's Haskell, I don't remember, or something, I don't know. Like, you can think of a lot of uses for this character, and now we're able to use them. At least on US keyboards, it's a very easy character to hit. It's right under the right hand. There's like no shift required. So that's important. It's good. It's a good key to have at your disposal. And if you burn it on character literals, which you're never going to type, then that is a waste. So well, we're not. So someone is saying they feel strange about character being distinct from a string if it's not a byte type. Whether it's a byte or not is immaterial, really. I mean, it's just an element of the string, right? I mean, I guess the real confusion there would be that maybe you're not used to thinking about UTF-8 strings. Because if you pull a byte randomly out of the middle of a UTF-8 string, it might be the middle of a character and might be meaningless without context. So even if it is a byte type, you may not be able to do anything good with it. Like, you need to be thinking about what your string is in context. That's sort of the switch that happens when you go from only caring about English to caring about all the languages. And that's sort of an unavoidable complexity because languages are complicated. Someone's complaining a bit that this is inconsistent with other type declarations. No, it's not, actually. No, it's not. This is not a type declaration, right? This is saying, give me a character literal out of a string. The type of this is actually U32. So you could say x U32 equals char O, right? This is the type. We're not making a separate type for character. This is a directive to extract a character literal. I should have been more clear about that, actually. Sorry about that. Char is not a type here. That wouldn't make any sense. You're right to point out that that wouldn't make any sense. Okay. Let me actually stop answering questions for a bit, and I'll type some more, and then we'll do some questions. All right, so if we try to run this, it ain't going to parse. That is clear. Invalid top level directive name, blah, blah, blah. Okay, so that's reasonable. So let's first go into the lexer. And let's look for the single quote. And, you know, what we did before when we got a character literal was we said it was a number of unknown size. That's what all this code does. And we're just going to comment all this out. We'll delete it later. Yeah, it's interesting. There was some redundancy in the code because I had to do stuff like \n for new line in the string processing as well. And now we'll just be able to reuse that, I think. I hope. All right, so that's gone. And what we're going to do then is we're going to handle expression level directives. There's a few places that do directives. I think we want to put it in this thing, parse directive. I'm not 100% sure. Let's see where we are. Because there's a few directives that I put only in certain contexts. Like in lambdas, for example, like a foreign directive is only accepted when you're in a lambda. Okay, so parse expression, helper. This is used to parse any general expressions in the language. If we get a hash mark, we eat the token, or no, we don't eat it. We look at the next token. If it's an identifier type, that's a different. Why did I make that not be a directive? I don't know. Well, I should probably factor that into parse directive here, but whatever. Let's go into parse directive. Okay, so in parse directive, we eat the hash. We see what the names are, and here I just frickin' stir comp on the names as straightforwardly as you like, and we do stuff each time. So we're just going to add something, and we're going to put it, I don't know, we'll put it at the end. Doesn't matter much. So if the directive name is char, then we're going to parse an expression. If we don't get it, we're going to report an error at where? Do we get a site in here? No, but we're in parsing. The thing is, like, I have a token, but that token may be gone. I let the lexer throw away tokens after you parse new stuff. But I just won't pass a site because we're in the parser. It should be fine. If you don't give the error reporting an explicit node telling you what site the error is on, then it uses the site where we have parsed up to. And we'll make sure that that works in our test cases. So we're going to report expected expression after char directive. Okay. Return null. If expr type not equal to ask literal, well, okay, bool is a string is false. If it's a literal, we got to check, because strings and numbers get put into the same struct. Static cast to ask literal expr. So we've queried that up. Let me show you literal. So here, if its value type is literal string, then we can look at the string value. So where'd we go? If literal value type is equal to literal string, you know what, instead of making this a bool, I'm going to do this. UTF-8 string literal is null. String literal equals literal string value. So if that's null, if we didn't get it, you report an error at the expression. Expected a string after directive return null. Okay, now we have a string. Now, I want to, first of all, I have a little Unicode support library here. Library is maybe a little bit too big of a word, and I've hacked it up a little bit. So basically I can do this. I can say, okay, wait, is this, I might have to, I have two different types here. Let's see what happens. So, int length equals length in characters, Unicode length in characters, string literal, if length is greater than 1, we'll report an error. Expected a single character string after char, but got a multi-character string. Return null. And if length is equal to 0, but got an empty string, okay, and then just to make sure we don't mess anything up, we assert length is equal to 1, and we say I have some way to get a UTF-32. Yes, so I can say result equals Unicode character UTF-8 to UTF-32 string literal. Yeah, it wants a source length. I know string literal is 0 terminated. String literal source length and I'm looking at this. So source length, and I have to give it a UTF-32 return value because C++ doesn't have multiple return values. Okay. If result, what are my conversion results? Not equal to Unicode conversion. Okay, then we'll also complain. Invalid Unicode sequence after char. Return null. Otherwise, we have totally succeeded in theory. And so let's go back and look at what I commented out in the Lexer and do that. So we're actually going to make we don't want to return a number. Okay, never mind. This thing actually made a token, but we don't want to make a token because we're at a higher level of the parser. We want to make an integer literal. Make, and I have a function to do that. Auto. I already have something called literal, don't I? Auto output. I have something called result and something called literal. It's like, auto output, or no. Oh, I'm overriding result. I don't want to do that. Okay. Why not? Conversion result. So result that's being globally used by every case and then being returned down here. Let's get rid of that. Is going to be none of this. It's going to be result equal make integer literal interp and value, and I'm probably going to have to cast that at some point, but whatever. We're just making it work. And that's it. That, I think, is all that we need. Let's see if that even compiles. I just typed a lot. It won't, right? Um, character, none of the two overloads. I have two character, UTF-8 star, UTF-32 star. Yeah, their UTF-8 is a different type than my UTF-8, so I think that's what's going on. I wish C++ would tell me better. Why do I have two overloads? Let's look at that. Character UTF-8 to UTF-32. Oh, one of them doesn't know the length. You know what? Let's do the non-length version. Wait, I deleted the wrong thing. This is what happens to me when I'm streaming. I just delete wrong things all the time. So we pass a value. We get that. And we're going to cast this explicitly to UTF-8 star. Because that's Unicode's type and not my type. All right. Let's see what happens. Hey! How great is that? So, well, so let's go back to the Galaga thing. Actually, are there any questions about what I just did? Does anyone not understand? I'm sure some people don't understand, but is there anything that I can answer that will be helpful to understanding what I just did? Wow, I'm looking at the camera and my face is totally cut off. I don't know what's going on with my camera lately. I'm going to move it back. Move it back. Questions? Does anyone have questions? Nah, bro, I'm cool. All right. Anyone else not cool? I like this, doing a concrete feature during the stream. It's fun. Let's try out some of the error messages before we celebrate too hard. If you have a question, please do ask. I'll look again in a second for questions. But before we go to a bigger program, let's go to our thing here and try some stuff out. So remember, in theory, this should not work, right? Okay, we got a multi-character string. Okay, that's great. We'll get an empty string. That works. No expression. Expected expression after char directive. See? Look, error messages that tell you. They tell you what happens. It's great. Okay. Let's put some Chinese in there again. Let's make sure that works. This might not work for some reason. Oh, so Emacs wants to know how to save it. I hope this parses correctly. It might not. All right, it parsed fine, and I'm assuming it outputted fine. It's just that this terminal does not understand Chinese or how to print it, because Microsoft is not like a world-class software company that's capable of text drawing or something. And this is their command shell. If anyone knows a better command shell, I should switch up command shells on Windows actually sometime. Command.exe just doesn't cut it, even with their much vaunted, silly, minor modifications they're making for Windows 10. Someone says, what if the expression is not a string literal? Okay, let's do that. 57. Expected a string. Did we fix the autocasting thing? I fixed that this morning off the stream. Yeah, that works. Why does it have to be a directive instead of just a keyboard char? Well, I kind of don't want to burn too many keywords. And it is a little bit arbitrary, honestly, what is a keyword and what isn't. In general, the idea is sort of, if you see this, it's sort of a compile time operation, but that is a very malleable concept. So extract something from this string literal is a completely compile time happening thing, and I don't want to eat all these keywords. Like, you might want a variable named char, right? If I ate a variable for every single thing, it would not necessarily be good. But it is a little arbitrary, because like I didn't say that that's hash cast, right? But casting sort of is well, casting can cause runtime code to be generated, right? Whereas this never does. So I don't know. I mean, really what I'm presuming is going to happen is that when the full first version of the language is designed, I'll go back over it and re-question all these decisions and see what makes sense. But in a knee-jerk kind of way, this was the decision that made sense to me at the time, and so I just did it. That's the real answer, right? Now I'm going to click on some links. Someone's asking me, am I assuming all the files are encoded a certain way? I am going to assume that all text files are in UTF-8. I think that that's a drastically effective simplification, because remember, I don't want tools to like get in your way or whatever. So there's an input standard for this language, which is that you're in UTF-8. You don't need to specify the format or anything. It just is. So that's all. Okay, let's go back to the font. Well, let's try to run. Well, let's just see. This should work, right? Yeah, it appears to work. Like I said, we're not necessarily even really using that code path, but hey, it parses in a more complicated program. Let's go do the one other thing I'd wanted to do, which was see what happens when we try to parse the old version of this. And just make sure that we get a reasonable error message. Where is it? There it is. Okay, unable to see RHS of binop. That's not necessarily the best error message, but on line 11, it's because, you know, this equal is the binary operation, and this is confusing it. This is generally an error message that happens when you don't do something user-facing in front of it that gives a better error message. And I would sort of go in and do something about this right now, except it'll automatically fix itself when we use single quote for something later. So it's like, why waste the work now? What I really wanted to do is make sure we don't crash or do something wildly wrong, like give you one of those error messages that doesn't give you the right location or something. That would have been bad. I think char works. Oh, no code changes. All right. So I was going to go out at 8:30 again tonight, but it seems like we have time to do some more things before that. So I'm going to take a short snack break and be back in a few minutes, and we'll do another new feature, I guess. Maybe we should vote on features. I don't know. Sometimes I like the community feedback, and sometimes I don't. Okay. So we did that. Okay. What are small features that we can do in the stream that are fun? You know, none of these are fun. A lot of this is just cleanup work. Oh, here's my list of stuff. Okay, let's talk about features that could be cool. And some of these, I'll let you guys vote during the couple minutes while I'm away. Some of these are going to be too big. In fact, all of them are probably too big. Oh, I did this one. This was the one that we just did. Okay. So the top one, deal with new. This is shorthand for, if you recall in the previous stream, I said that when you do something like this, new 10 int, right? What we would like is for that to be a language array, you know, that gives you a value and a pointer. And right now it's just the pointer part. So that's not an amazing feature, but I got to do it sometime, and it lets us clean up the code, which is nice. And this requires work in the bytecode builder end of things, which we don't do so much with. Like, notice that everything I just did was very far in the front end. Like, we didn't touch the bytecode builder at all, for example. So that might be interesting for that reason. Structured note, everybody complained about notes, that you have to parse the name of the note. We can go back to that and make them structured. And the way that I decided to do that was to let it use the name of another struct that you declare, and then the arguments are just the types of the struct members. And the nice thing about that is that then you can be sure that a note is your struct, because you can compare. Like, suppose there's some system vector 3 that everybody uses, and you want to put a note on it, but a library also wanted to put a note on it, and you guys happen to pick the same name for a note, you'd be able to tell the difference because your struct is in your namespace shadowing their struct in their namespace, right? So, and that would get rid of everybody's gripes about not wanting to parse notes. That's going to be too big of a job to finish in this stream. I mean, all of these might be too big. We'll see. Flags. So right now, flags are done exactly like in C++, but I want to do something like where you say, modes. I want to make a keyword called enum flags, where you just go mode A, mode B, mode C, or whatever. And these, in the same way that enums get sequential values, these would get sequential flag values, right? And if you wanted to specify them, you would specify them as integers the same way as always, right? So this is the same as enums, but behind the scenes, right, this generates these usual flags. So you don't have to do all that tedious bookkeeping. And then the reason that that's good is then because the program knows that these are flags, if you have a struct, S is a struct, and it has modes on it, right? We would do something where you could just say S dot mode A equals, true or false. Like, you'd be setting all these flags inside this flag word, but you wouldn't have to. You do all the stuff where you say S dot modes or equals mode A and equals not mode A, which is, it seems like a relatively small syntactical thing, but then by the time you've done all this, then instead of even declaring an enum flags, you could just put them as bools. You could say mode A is a bool, mode B is a bool, mode C is a bool, mode D is a bool, and those could be automatically compacted into a single flag word, unless there might be some reason why you'd want a standalone bool, like if you're doing thread safety or something, but like atomic operations, I don't know. But anyway, there's something there. What I just said is a big mess of ideas, but there's something there that could be cool, right? Like, I'd rather just say this than this, right? Because here I could start out, or a thing that often happens is you end up putting bools into a class, and then you want to put all those in an enum, and then you have to change all your code, right? Here, even if we didn't automatically coalesce bools, the syntax of this is the same whether our declaration is this or that, right? So that's kind of cool. Anyway, so that's that idea. CoffeeScript style question mark. This next idea is, like it's a way of dealing with null pointers without specifically doing option types. So if you say, if you need to say A and a.x and a.x.y and a.x.y.f is equal to 3, then do something, right? You're doing all this tedious checking. And so you could do something like, instead of all that, if a dot question mark x dot question mark y dot question mark f is equal to 3 dot dot dot, right? And what this does In a strongly typed language, this has, or, okay, if you want to make this even more terse, you could just do this, right? And this is like a dot with a little extra squiggle on top, if you want to think about it that way. And so what this is basically a shorthand for this whole thing, except you also need to look at the type of this right-hand side and return the 0 value of that type, right? Because, you know, if x is null, then you're not going to go further down in this chain than x. So you need to return something for this expression, and it should be 0. But if this is like a pointer, actually, and not an integer, if it's a pointer to foozle, then you want to return null, right? So this question mark chain has to be sensitive to whatever's on the right-hand side, which is kind of interesting, and I haven't totally thought about what the best way is to do that. Hanging array? Oh, God. Yeah. We could think about that. You know, in C, okay, so next feature idea is hanging array, which is, you know, if you're in C or C++ again, you can say struct x, and you can say int a, b, float c, right? And then you can say, I'm totally getting my syntax messed up between languages. You can say D is an array of doubles, right? Well, not double. Let's say characters, whatever. I don't know, floats. Let's do floats. We're going to do an array of floats, right? And you can do this thing in C, which is, here's an array, and it doesn't take any size in this struct, but it's hanging off the end. So I can allocate off the end. Now the thing is, we don't do range checking yet, but if you do range checking on your arrays, then it's going to get pissed off about this, right? So hanging array would be that you would explicitly designate that, and during allocation you somehow specify that. Although, you know what? This one, I think, let's not do this one. That's out of the running because you kind of want parameterized types first, or polymorphic types, because this may fold very easily into polymorphic types, and we don't, or polymorphic structs. We don't have that yet. We only have polymorphic functions. File scope directive, which right now everything that you declare in a file is global scope. So we could put a file scope directive in the middle of a file that says essentially that everything inside this directive is private, right? And then if you get an undeclared variable, the compiler can search and tell you which scope it's in, which would be, it could tell you like, okay, look, it's really at this location, but you're not reaching it. Okay, that was a lot of talking about potential features. I'm going to go get another drink and a snack, and I'll be back in a second, and you guys can mull this over, and when I get back, you can express an opinion about what we should do. What do people think? What do people think? I don't want to scroll back, so when you see me start eating the cookie, you can vote, and I'll read while I'm eating the cookies. Right. Function overloading is not implemented yet. So that's actually another thing. We could do function overloading. Or operators. We should probably have function overloading before operator overloading, honestly. Oh. Here's a poll link. Flags 9 votes, CoffeeScript 8. Really? Flags is winning? I am surprised. Nobody wants structured note? After all the complaints, dude, when I did that presentation with the notes, everybody complained about the unstructured notes. It was amazing how many people complained about that, and yet nobody wants it now. Nobody wants it. Okay, wait, CoffeeScript style thing is back in the lead. It's very close though. Flags is in second. I don't know why so many people. I didn't think flags are cool. I like them, but I didn't think it was such a topic that would get so many people excited. Maybe it's because I talked for a long time about it. Oh, my picture is over structured note. Well, I mean, anybody who saw the notes presentation knows what I'm talking about. You know? Someone's saying they'll never learn how to code. It's actually not that hard to learn how to program. I learned when I was freaking 10 years old. It can't be that hard. Seriously. It's not that hard. Someone's asking, if we do the question mark thing, how would we implement an OR operator to work with it? I'm not sure I understand the question. Can you give an example of what you want to work? Because it seems to me like it's implicitly an and. Like, I actually don't know CoffeeScript or a couple of other languages that use this stuff. So I'm actually not sure if they actually do something good that I should know about. The only part of it that I know about is what I just showed. Would I please use Evernote? For what? All right, we're going to do the question mark. That's narrowly won over flags by 1 vote, 10-9. Although deal with new came in close. That's 8. Why is someone asking me? Whatever. It is, you know, if you want to be a top skill programmer, that takes a lot of work. But the sooner you start, the sooner you get there. If you keep putting it off because you're like, oh, it's so hard or I'll never learn, you're just putting off the date at which you become the best programmer in the world, and that's not very nice to the world, is it? Yeah, so that's a thing. So there's a few, someone's saying Swift has something like this, but it skips the entire statement if it's null. And there is, you know, you could imagine something like that where you say, instead of it being an expression like I just said, in fact, maybe that's a more useful version of it, right? Because let's say you're calling some function, right? And you're like f of 1, comma 2, comma, and then instead of x dot y, right, you're saying x question mark y. Well, one version of this is you get a 0 value into the function. The other version of it is you don't call the function. I'm not so sure I like that second idea because this could be arbitrarily deep and it could lead to very confusing code, right? I don't know, like, I mean, you could, well, 3 is not going to have a, I don't know, you can start imagining nesting this deeper and having things nested off this, like maybe there's a lambda in here, right? It's maybe starts to become unclear that this isn't going to run just because there happens to be a question mark in there. But then maybe that's something your IDE can do anyway. However, the 0 value version of it is, I think, probably easier to implement because here, this is a superset of that, I think, because you have to generate a truth value. To do this, you have to generate a truth value and then bubble an if statement up to here based on that truth value. I don't know. I think it's maybe a little bit presumptuous to do that because I'm not sure it's really what you want. But I don't know. What do people think about that? Like, would you rather have it always call this function, right? I think I would rather have it always call this function. And if I wanted to not call the function, I'd rather have an explicit if, right? Like that. Because this really tells me flow control may not go into that function, right? But again, you know, maybe with good IDEs that highlight it the right way, things can happen. I don't know. Someone's asking, how does this syntax fit with the ternary operator from C? It doesn't fit with it because, again, just like with the hash char thing, we're picking our battles. I don't think the ternary operator is that useful. By ternary operator, I mean this one, right? This question colon thing like you have in C and C++. We just don't do that, right? And the reason is, I think something like this is a much better use of question mark than this, right? If we wanted to do something here, because we feel like we miss in some rare circumstances what the ternary operator gave us, maybe you put something there like I don't know, hash then is maybe the wrong thing, but you know what I'm, like some expression version of if, right? Like that's a little more typing, but you hardly ever use it, so it should be a little more typing. So that's what's happening here. Now, the thing I would be concerned about in implementing this is, you know, we might want to do option pointers later, and an option pointer, you know, instead of saying x is a pointer to an entity, right? It might be x is maybe a pointer to an entity, right? And maybe we want this question mark here, and maybe that makes it more confusing in expression context. Maybe it doesn't, you know? But I'm not that worried about it. Like when we go to implementing this, if we do, we can always make it double question mark or something, and it'll be an ugly syntax for a while till we figure it out, right? Anyway, So I can start on this if there aren't any other questions about what we're going to do. Maybe some of it will become clear. I don't think we're going to finish in the time allotted, but that's fine. Any other basic questions, or does someone want to tell me anything about how CoffeeScript or Swift or any of these other languages that have this work that I should know before I trundle into this naively? It's a good question. Someone is asking, am I going to just return 0 value for whatever type the member is for, x.y if x is null? No. And the reason is, the right answer is not whatever type the member is for. Because presume you do this. Say you know that if y exists, z will not be null, right? The return type of this expression has to always be the type of z, right? So even though you're saying you're testing y for null, the 0 value needs to be z's 0 value, not y's 0 value. So it's a little bit more subtle than you were asking, but it's a very good question because it determines what we're about to do. And this is what actually may make it slightly challenging and may make me want to clean up some other things. Yeah, I don't know. We'll see. We'll just see how it goes. So someone's saying, so in a string, I'll type out what the next question is. In a string x, y, z dot some struct, right? If some struct is a value, then you would get it initialized to 0. In this case, if this is a struct by value, maybe it's 0, but maybe it's the default value. This is something that we would have to decide in the language semantics, right? Maybe you just want a freshly initialized one of these. I don't think of this as a very common case, that it's something weird by value, right? But if it is something weird by value, I feel like we don't want to introduce another concept besides what is the thing with all its default values. So I think you would get a default constructed one of these is going to be my knee-jerk answer, but that might be the wrong answer and we might have to change it. Anyway, all right, so let's just start doing this, and we'll see how far we get tonight. First thing we got to do is look in the lexer and make sure we pass, well, let me get rid of this thing, first of all. We don't need this. We didn't even use it. I'm pretty sure that I passed question mark, but let me see. Yeah, okay. So the lexer already passes question mark as a one-character token. Actually, okay, let's write our test program before we do any of this. Let's go back here. Let's get rid of this stuff. We'll make, I don't know, let's make a linked list, right? You shouldn't really ever use linked lists, but let's make one. So we'll say list node is a struct, and it has a next. That's a pointer to a list node, pointer to a list node, and value is going to be a void pointer because this is not a type safe list node. We can't make a type safe list node yet because we don't have polymorphic structs yet. We will eventually, but and a list is going to be a struct that has a head, is going to be singly linked, so that's fine. And that's it. This is going to be a very simple thing, right? So we're going to say we're just going to set up a list, in fact, right? So we're going to say head equals new list, or list equals new list. A equals new this node, A, B, and C. B dot next equals C, A dot next equals B. List dot head equals A, right? And then we're just gonna, here's what we're gonna say. We're gonna say if list dot head question mark A, right? No, not question mark A, right? If list, how do we want this to be? We can already do, we already know that list is not null, so we don't need a question mark here, right? If we thought that list might be null, we would put one there, but we're not going to. We're just going to do this. Printf head exists. Let's just do that. Let's make sure this even parses. Undeclared identifier list, right? Because I didn't use declarations. Sorry, folks. It's like I can't even program or something. All right, head exists. So that's great. It's a very sophisticated program. So we're going to start using the syntax. Well, let's do this. Dot A, dot B. So this should all work. Oh, right, except they're not called A, B, and C, they're called next. Dot next, dot next. Dot next, dot next, dot next. Wait, oh, A is the head, right. So that's B, that's C. That's D. This is going to break, though, as soon as I add another one, because now we're dereferencing a null pointer, and that's no good. We're going to crash, right? So this is why we want to use an operator for stuff like this. I mean, this is a really stupid example, right? But this is where you would want to start doing this kind of thing. Right? So now the compiler is not going to understand. The thing I don't like about the question mark, and this can be handled with syntax highlighting, but the question mark fills in too much space between the names and it makes them blur together, right? But again, if this is drawn a different color, maybe you can read it better. I don't know. We'll see. Question mark might not be the right character. Maybe we want our single quote that we just liberated. A single quote is sort of like an upside down period, right? So you could do that. I don't know. We'll see. Anyway, so this is not going to parse. It's going to like, okay, I don't know what you're talking about. On line 29, let's make sure it's the right line. Yep. Okay, so what do we do here? Well, let's make the parser know what to do. And here, for example, we have that dot is a binary operator. It's got a precedence of 10. Let's give that the same precedence. We'll tell it that it is a binary operator. All right, and then let's see what the compiler does with that. Doesn't like it because there's a binary operator that it doesn't know what to do with. So that's not too surprising. We just have to do some things here. All right. What do we want to do? So in type, this is for type declarations actually. And I don't think we want to support that, right? So there are two contexts in which you can use dot right now. One is the one we've been talking about when you have like some struct and a field, right? But you can also use this, right? Remember, dot just dereferences namespaces. So you could also say, you know, y colon mathlib dot vector 5 equals k, right? And so we're not going to support question mark in this version of using dot, right? Only in this one, the expression value. But let's go ahead and put an error message here so that if somebody does this, we say that doesn't make sense, right? Else if token.type is equal to question mark, interp report error, operator question mark does not make sense in a type declaration, return null. All right, so let's look for the other one now, the expression context version of that. And I think that that may just be, yeah, there is no thing that handles it by dot in quotes. What happens is someone calls isBinaryOperator on binary operators generally. So down here we're parsing expressions and we're doing a whole bunch of things. If it's a binary operator, then we parse the thing on the right, we make this binary in left and right. And so we actually, in theory, shouldn't have to do anything else for parsing, right? We just need to think about code generation and type checking. For type checking, the type of this is always going to be the same as the type of dot, right? So let's go to that. Here's a thing that type checks dot references, and we can actually just do this. Oh, I have this. I think that's a good note. However, oh yeah, okay. This is interesting. There's a larger issue. Remember with all that dependency rewriting that I did, you know, I flattened the expression stream. And so when you have something like, you know, s.f, or let's just say x.y, there's two places where the value of the expression ends up living. So first of all, you have a binary, you have a node called binary, right? And it's got left is whatever's in x and right is whatever's in y. And the type of this binary needs to be resolved, and that's what happens here. But also, because we flatten this thing out and we resolve these identifiers at different times, and we may have to pause in between them based on who's not loaded yet. Like maybe I know what x refers to, but its whole namespace isn't completed yet, so I can't look for y in it, for example. Or maybe x is completed, but there's a block standing between me and x. Actually, no, that's not right. Never mind. First thing I said. So in that case, right, then we also just have an inferred type on y, and y is like an ident where we say struct dereference expression equals x, right? And that has type t also. So there's like two places where hopefully the same thing happens, and that's what this redundancy message is. I'm going to promote this into my to-do list, but I'm not really going to deal with it right now. I'm going to deal with it later. I'm just going to make it work right now. Yeah, that's where we were. All right, so But I think both of these will work anyway, because this thing on the left doesn't have to do anything new. All I have to do is make sure the struct dereference expression gets set, which actually happens here, I think. Yeah. This is a time when, like, I'm going to go through a bunch of cases and do this. Maybe I should make a function for this, but you know, like is a dereference operator function that basically has this. But this is a thing where in C++ you would rather say, like, if it's a subset of you know, that, right? But we can't do that in C++ without ugly horribleness that the disease, the cure is worse than the disease. So I'm just going to do this. It starts to be a little harder to read, but we don't do it in that many places. And if I don't like it, I will abstract it out. All right, so that sets our struct dereference expression. None of this code that we've looked at so far actually needs to know the difference between dot and question mark, as far as I know. However, well, maybe during type checking time, I will want to. No, I don't know. I'll need to think about how I actually generate the value, but it may all be contained inside the bytecode builder, all the actual special casing. So I'm going to do that here as well. Okay, so let's go back and make our program not crash if dot means the same. So I want to, if things are, oh, let's go into bytecode builder. Well, let's make sure this compiles before we go any further. It doesn't. Illegal use of else without matching if. Really? Oh, that's the while loop. Put it in the wrong place. I don't like Visual Studio's indentation defaults. All right. Token arrow type. I get too used to nice languages where dot and arrow are the same thing. Hey, look, I left all this garbage in the file. That's certainly not going to compile. Hope somebody caught that. Could I theoretically add this null checking short circuit behavior to dot instead of adding the question mark? No. No, because you want dot to be fast, right? You want dot to be fast, and what we're about to do with question mark incurs runtime overhead because it essentially inserts a branch into the middle of your code that checks things and does stuff based on that. And if that code was getting generated for like every single time that you're referencing something, then that's no good. So we're not going to do that. That's something for a squishier, slower language. Although it is safer, right? If dot did this all the time, then your code is much safer. However, it's not what we're doing here. Okay. So now that that compiles, the bytecode builder is still going to assert. Let's verify that that's true. Yeah. So that's the same thing that we got before. Let's go tell it that dot, that question mark is the same as dot, right? Emacs. I need better key combinations. Yeah, you know, I really should make a function for this. Make a function that use is a dereference operator everywhere. I'm just going to make that function now. after enough pasting of the same thing, it's like, all right, we should do this. Bool is a dereference operator, int token type. If token type is equal to dot, return true. We might add another dereference operator later, for all I know. Return false. You know what? I'm just going to go back and, forget it. So is a der operator I'm going to use that everywhere in all the files. I'm going to be a good programmer and do the right thing. Okay, so this is the thing that tells it what code to emit, and the fact that it didn't hit this was what caused that assert, probably. Whoops. Ooh, that's a bad kind of bug, because I think C++ would have auto-casted that. So let me check. All right, so now I'm going to put this in a header file where everybody can see it, which I shouldn't have to do, but this is C++ and it has header files. I'm going to put this into maybe Parser. I don't know. Where should it live? I don't know. And now I'm going to go and replace a few of those things that we did. Not there, because switch statements don't work that way. I still don't remember how to pop the kill stack in Emacs after all this time. All right, let's see if that compiles. It did. Let's see if it runs. It did. Okay, this is good. We have a little more time, but what we've basically done so far is we've just made question mark be the same operator as dot, right? And through a lot of the front end of the compiler, that should be true, but then later toward the back end, they should differ in terms of what they do, specifically in that code generation, right? Let's, forgot what I was going to do. Let's just show that this still crashes, for example, right? This is going to crash on this part because question mark is the same as dot now, and we're going too far, right? There we go. So our next task is going to be to make that not happen, and maybe we can kind of get that done. Maybe. This is the part I need to think about. You know what, since these are all the same type, I can do sort of the Kmart Blue Light Special version that assumes that the type of the right-hand operand is the same as the type at the end, because for this example it is. And we can make that work, and then we can do the more sophisticated thing of knowing what's at the end. And we will have to make a separate test for that. And I know I'm not going to get to that tonight, so maybe we'll do it a different night. Make it work such that question mark handles a different type at the end. Do we have questions about what I've been doing so far? Question mark dot is using it. Yeah, we can make it a question mark dot instead of question mark. That's a very trivial change. You know, instead of checking for the specific character this, all one character tokens get passed as that. We would just make like a token optional dereference or something, and we'd put it in that as a dereference, and it would drop right into what we just did. So you know, making it that is easy. I just wasn't sure that I wanted to make it that, but maybe first thing in the morning I'll wake up and say, oh, I should have made it that, and that'll be fine. one of my is a dereference used to be x is not equal. Oh, that's a good catch. Really? Oh, yes, you're right. Yes, you're right. I remember sort of. I don't remember really. It wasn't this one. Because this actually wants dereference. It wasn't in parser because we don't use it in parser. So we don't use this in parser. I'm going to move it to code manager. It must have been in bytecode builder. I think it was this one. I think it was that one. Does that look familiar? Oh, I checked it in. Batch R819, is that how that works? Yeah. I should have used a visual diff program. All right. It's so hard to read. Okay. Right, so that's a not equal, and we've now made it not is a dereference operator. This one is equal. This one is equal. Okay, you are not fired. You are continually hired for catching that bug, because that would have been a very annoying bug. And someone's trying to copy you by popping in later and saying what you said. I think that's the first time someone's been explicitly not fired on the stream. All right. I'm getting tired and probably want to head out soon, but let's start. Let's start on what the bytecode would look like, presuming that the type is actually the local type of our right-hand side of our expression, right? So again, we're going to cheap out in the beginning. This is the way I do a lot of things. I'm going to cheap out, and I'm going to say that I know that this type is the same as this type, or you know, this type of the thing on the right is the same as the type at the end of the expression. And we'll write that. We'll make it work, and then we'll go back and make it better. When is game 3 getting ported to the new language? Well, it is, but not for a little bit, because we kind of have some other games to finish first. I don't know if you've heard of them. They're called The Witness, for example. Yes. Alrighty. So let's do some bytecode building. Okay, so essentially, this is tricky. Okay, so we want emit code for struct dereference. Not this one though. Emit code for not that one. So when you do a using of, remember in one of the earlier demos, I did usings in some really complicated ways, like, hey, I'm using a function on a guy and whatever. And you can walk down a chain of objects to get to that thing that you're using, right? If they're being used by the struct, right, they're being included anonymously. So you can end up navigating a hierarchy, and that generates struct dereferences behind the scenes, right, in the bytecode. So I guess I do that too. All right, whatever. For struct dereference. Who's calling this? That's just recursing. Okay, so this is the one for the binary operator. And let's, what was our function called? just to make sure that we know what's going on, let's assert that this is a dereference operator. Token type, binary operator, token type. That's a dereference operator. So now, this is actually quite a complicated function, or it's not too bad, I don't know. So some of these conditions even don't apply. Like, here we test to see if something's a fixed array, which is like a C array where things are of a known length. And you can say .count and .data on those. In yesterday's stream, I was talking about how I implement faux data structures for the other cases that have data footprints. But a fixed array has no data footprint. The data pointer and the count are known at compile time. And so this is the thing that actually handles that. But if you're dereferencing that with question mark, who cares? Because it can never matter, right? So, you know, if it's a constant, what happens if it's a constant? If it's a constant, then you obviously, the thing it's in is not null because you're dereferencing a namespace that's full of constants or that has constants. Or it doesn't, even if you have a null pointer to some thing of a class, you don't want to dereference that to get at a constant that's inside, right? So like these early, I'm just going to say, these early cases do not care whether we are using dot or question mark. Okay. Now here's the stuff. Oh, all right. Well, this is pretty easy. So all this stuff, the left register is now the thing we are about to dereference. Right? Our expression on the left of the dot could be an arbitrarily complicated thing, right? We could be saying like f of x, y, z dot field, right? So this evaluates whatever that arbitrary thing was. And now that we've got that back, we do this. So actually our task is relatively simple, which is if token type is equal to question mark, do something conditional here. So we essentially need to generate an if statement at this point, right? So let's it's almost tempting to actually do this earlier and insert an if statement into the syntax tree, except we don't have expression if, and we need expression if. So let's not do it that way. Let's do it bytecode way, which might be better. It might not be better. This might be the wrong level of abstraction to do this. Okay, so emit code. Let's just let's look at emit code for if for a second, right? We generate the register holding the result of the expression. We make sure we know what its size is. This is not really that meaningful. The slot where I put the size field in my bytecode is only 32 bits, which means if you do an if right now by value on something that's bigger than 4 gigabytes, the compiler will not handle it correctly. So this temporary truncate to S32 thing is just a thing that asserts that you're not doing an if on something more than 4 gigabytes. And that's a piece of slop that I'll clean up later. That's the only reason that this exists, is to yell at me if you do that. Okay, so, or more than 2 gigabytes, I guess, because it's signed. So then the way that ifs work is you need to, you generate code for the expression, and you generate code for blocks, and then you note where you are, and you generate a goto, and then you have to go back patch the goto, right, with the address. So let me try and so here, we evaluate the if, and then we say, okay, if that expression is false, go to some constant. But we put a -1 in for the constant because we don't know where to go to yet, because we don't know where the end of the if block is. That depends on how much code is in the then block, right? So we generate the code for the then block, and then we note where we are. And then if there's an else, we generate that, and then we note where we are. And now we have two goto points here, right? And so we go back and we grab the instruction for the if part, and we stuff into index A, which is the slot in that byte goto instruction where the destination address lives. We put the then jump position here, right after all the code of the if. So we execute the then, and then we jump to the end of the if. For the else block, we need to generate the else code. Actually, wait, I explained that wrong. These variables could be named more clearly, probably. Okay. This is the end of the then block. Right? And the reason we do this is because if there's no else block, then after your then block finishes, you just keep going, right? You don't need a goto. This is an optimization, right? If there's no else, then after you do the then, you just fall through. If there is an else, then after you do the then, you need to go somewhere. And where that is the end of the else block. So we emit the code for the else block, we get the else end position, and we stuff that back into this instruction, right? Yes, into this instruction. So, and then we do the same thing, if the condition on the if is false, we do the same thing, except we jump over the then block, right? So we generate the instruction that jumps, we leave the address empty, then when we figure out later where the address goes, we paste it in. Okay, so I'm going to block this out in pseudocode right now, and then probably go party for tonight. But, okay, so here's what we do is, what are my go-tos that I have available? So we have go to constant if false and go to constant if true, etc. So we want to say if this is interesting. This is interesting. What I've said about dot and question mark being the same through the front end is not necessarily true, because we need to factor our expressions differently. I'll explain why in the next stream if I don't do it before the next stream. Anyway, here's our pseudocode for what we want. If left register is false, we would dereference null, because null is 0, right? Null is just a typed version of 0. Therefore, skip all the rest of the code on the RHS of our binary tree and return the appropriately typed 0 value, right? Else, just fall through and do the code below. All right, so that's actually kind of straightforward. So So actually, here's what we want to do. I'm going to invert this logic. I'm going to say, if left register is true, jump to destination, right? And this code is going to say, no, jump to, okay, wait. How do I do this? I want to try to do this without two go-tos. I can't, though, because it's basically an if then else. All right. If left register is true, jump to do right hand side. Otherwise, create 0 value of appropriate type, jump to done, and do right hand side is fall through and do emit code for struct dereference below. All right, so I'm just going to start doing this for a little bit, and then we'll leave the rest for the imagination for now. So it still compiles, great. Okay, so let's look at the if statement there. Again, code for if. We're just going to paste a little bit. Here we had a condition register that we're generating code for, but like I said, we already know what that is. It's this left register. So I'm going to try to name these better. So what this first thing does is this is the index of the next piece of bytecode. The reason why I have to have an index instead of a pointer to the bytecode is you could generate arbitrarily long bytecode, and our bytecode storage might reallocate in the middle. So you don't want to take a pointer to the bytecode. So you take an index to the bytecode. So what's this going to be? This is going to be called instruction index for, let's call it instruction for skipping instruction for jumping to right hand side. Naming is hard sometimes. Okay. Instruction for jumping to right hand side is note the location. Now, if true, right, we're doing this now. If the left register is true, what's the left register? It's this. That's left register. This is the jump destination, so again, that's -1. And we need to know the size of the left register, and that depends on the type. And we did that in the if, and I sort of skipped it because I didn't want to think about it, but let's jump back there. Code for if. So we need to know the type of that thing and get the size, just like we did here. And I'm going to leave this @hack note here, but drop the details. I think this may not be necessary anymore since my refactoring of the compiler. Because in theory, just like you infer types all in one stage, we should be initializing the size of things all in one stage now, iterating over that flattened array. So by the time we get here, in theory, we shouldn't need to call this. It should have been called. However, I'm not going to start changing things that, you know, the more variables you tweak at once, the more likely you are to have something confusing that you don't understand happen. So I'm going to leave a hack note here. Anyway, this should be clean up at this point. All right, I think we fixed this and no longer need it. All right, so the size, we are getting the size of binary left inferred type size. All right. So, oh, I need to do that here. Binary left inferred type. So we're initting the size, we're getting it, we're asserting that we got a valid size. Now, we check. Now, the reason we need a size for this register is because we don't know, what, incomplete. This code so far will only handle things of register size or less for a large struct